So 9.3 we're doing geometric sequence, and a geometric sequence is when you multiply by a constant in order to get the next term. Where arithmetic, we're adding the same number. Geometric, you're multiplying by the same number. And that number that you're multiplying by is called the common ratio. The common ratio is the constant that's multiplied each term. This should say to get to the next term, so that should be a 2 on the end. It just got cut off. The explicit formula, or the rule, is here in the formula down at the bottom. It's where you have a starting value of A and a common ratio. That should say ratio, not ration. R is of the form A, and then you multiply by R, you multiply by another R, so that would be R squared, you multiply by another R. In general, you can use this rule. A sub n is equal to A1. That should be times. That times is a little bit lower. I didn't get to fix that one. Times R raised to the n minus 1, where n is greater than or equal to 1. So here the question is, for these three, is the sequence geometric? If it is, find A1 and R, and then I'm going to ask you to write the rule. So for this first one, my A1, A sub 1 is always the first term, so that's going to be 3. What do I do to get from the first term to the second term? Okay, if I'm looking to multiply by 2. And to get, do I multiply by the same number? Multiply by 2 to get to 12. Multiply by 2 again to get to 24. And 2 again to get to 48. So this is a geometric sequence, and my R is equal to 2. So to write the rule, I have A sub n is equal to A1 times R raised to the n minus 1. So the rule for this one is going to be 3 times, if you want to put it in parentheses, that's fine, 2 raised to the n minus 1. It's only the 2 being raised to that n minus 1. And remember, you got to do your exponent before you multiply. So that's my rule for that one. And this next one, to get to from 3 to 6, I would multiply by 2. But to get from 6 to 9, I don't multiply by anything, and I can't multiply by anything to get from 9 to 12. This one is not geometric. If you notice, this one is actually arithmetic. Okay, and the last one, if I take 3 to the 5th and I'm looking to multiply that by something to get to 3 to the 10th. Well, notice the base is 3, so the base would be 3 for the common ratio as well. And what do you do with the exponents when you have the same base? You don't multiply the exponents, you would add the exponents. So to get from 5 to get to 10, I would really have another exponent of 5. So 3 to the 5th times 3 to the 5th would become 3 to the 10th. Well, if I multiply by 3 to the 5th again, that is equal to the next term again, because I'm adding the exponents, 3 to the 15th. You multiply by 3 to the 5th again, that will be 3 to the 20th. So this is geometric. My first term is 3 to the 5th. My common ratio is actually 3 to the 5th. Okay, and I'll write my rule up here. A sub n is equal to, you have 3 to the 5th, I'm going to put that in parentheses, times 3 to the 5th raised to the n minus 1. This one just looks a little bit different because the exponents, but don't pay too much attention or get too confused because of that. Okay, so for this one, the directions, the question is, what are the indicated terms of the geometric sequence? So they're telling me this is a geometric sequence. And they're asking for the 10th term in A. So I'm going from 4 to 12, then 36. So in order to find the 10th term, I'm going to first write the rule. and then plug in 10 for n. So my A1 is 4. My common ratio here is 3. So for the rule, I have A sub n is equal to 4 times 3 raised to the n minus 1. So to find the 10th term, 4 times 3 raised to 10 minus 1. Well, 10 minus 1 becomes 9. So 4 times 3 raised to the 9th. The biggest problem or issue people have here is not following order of operations. It's only the 3 being raised to the 9th. So do 3 raised to the 9th, and that's going to be 19,683. Times that by 4, and I get the 10th term is 78,732. These numbers will get a little bit larger because we're multiplying here. It's going to get larger a lot faster than just adding a number. Okay, and the second one, it's asking for the second and third terms in the geometric sequence. So out of the formula, I know the first term is 2. I don't know the common ratio here. I do know the fourth term is negative 54. Think about what has to happen for it to go from a positive 2 to get to a negative 54. Okay? And what we're going to do, set it up in the formula, A1 times r raised to the n minus 1. Okay? My A1 I know is 2. I don't know my r. Okay? But what else I do know is I do know my fourth term. My fourth term is negative 54. So if I plug in 4 in for n, that's going to be 4 minus 1 up in the exponent, but that's going to equal this negative 54. And I can go ahead and solve it from here. 4 minus 1 is 3. Okay, and to solve for r, first divide by 2. I get negative 27 is equal to r cubed. And how do I get r out of this? Because r is being cubed, the inverse operation would be to take the cube root. And then r is equal to negative 3. What that means, when your r is a negative, what's going to happen every time you multiply by it? Well, I'm going to go to the next page. I started with 2, multiplied with negative 3, and that's equal to negative 6. When I take negative 6, multiply it with negative 3, that's equal to positive 18. Positive 18 times negative 3 is equal to negative 54. So your two missing terms was negative 6 and positive 18. But what I want you to notice here is when the common ratio was a negative, what happened in the sequence is that every other number became negative. Okay, on your sheet you have two U-try problems, question 4 and 5. And then the bouncing ball one, I'm going to do that one in class and that U-try. So go to the back page and we're doing the geometric mean. So with geometric mean, it says in the geometric sequence, the square of the middle term of 3 consecutive terms is equal to the product of the other 2. Okay, so what that means, if I have these 3 terms, if I square the middle term, I get negative 6 squared is 36. That's going to be the same as the product, or multiplying the 2 on the outside. 2 times 18 is 36. Same thing would happen if you do it with the negative 6 times negative 54 would be the same as 18 squared. Because of that, to find the geometric mean, or to find the middle term of three terms in a geometric sequence, you take the square root of x times y, the square root of the 2 on the outside. So for this one, what are possible values? This should say of the missing term of the geometric sequence. Okay, not faux, it should say of. So what are the possible values of the missing term for the geometric sequence? I have 48, then I don't know, and then 3. Well, to find what that term is, I'm going to multiply 3 times 48, and that's going to equal 144. And then to take the square root of that, it's going to be 12. Okay, now notice it says what are the possible values. 12 could be a value, but also negative 12 could also be that middle term. If negative 12 is that middle term, all it would mean is that the common ratio is negative, because it went from a positive to a negative to a positive. Okay, look at this though. Look deeper into this and look what the common ratio would be to get from 48 to 12. Okay, what do you multiply to get from 48 to 12? Well, it's not really multiplying. You would actually divide, and it's actually positive 12 or negative 12. So you would actually divide by 4. Because you're dividing by 4, that means your common ratio, it's not negative 4, because that would make it negative and it will get larger. It's actually dividing by 4 is the same thing as multiplying by its reciprocal, 1 over 4. So the ratio in that case would be 1 over 4. Okay, just to get you another example of something that's a little bit different within the geometric sequences. All right, try the U-try problems, and I'll get a joke for you. Go ahead and try the U-tries on your own. I'll give you a joke right here. All right, here you go. Why did the old woman tie skates on the rocking chair? Because she wanted to rock and roll. All right.